The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and FreedomSlips.com, its staff, or affiliates. You're listening to Revolution Radio, FreedomSlips.com, 100% listener-supported radio, and now we return you to your host.
Ladies and gentlemen, welcome back to another episode of Cosmic Catastrophe on Revolution.radio. I am your host, Diamond, from the Oppenheimer Ranch Project, and joining us today is my partner in crime and my lovely co-host, Leah Shaper.
Hello.
That's a lovely necklace you have on.
Why, thank you. It's another one of my creations.
I made this shirt.
No, you didn't, but it's cute.
We've got a great show today. We're going to be talking about 4 articles and or papers, 4 topics. We're going to kick it off with something that you and I have discussed before and even posited that this is what was going on. And now there's a peer-reviewed paper that came out on May 30th saying just that, an unexpected global warming spike due to abrupt reduction in shipping emissions. Can you believe that? We're also going to be talking about the sun's magnetic field and the fact that the magnetic field of the sun could lie closer to the surface as opposed to inside the center, which was once posited. They refer to that as the dynamo or the double dynamo, and we'll get to that and maybe some of the implications for the electric universe model and the fact that our sun may be powered by a Birkeland current and not a thermonuclear reactor at the core. We'll also talk about geomagnetic superstorms and their effect on the rotation of Earth. This is poignant because we just had a superstorm. So we'll talk about that.
Very interesting. And it makes a lot of sense too.
If we have time, we'll talk about some new discoveries in Maryland on an island where they've been excavating there for over a decade, and they've dated tools to over 22,000 years ago. Yes, which pretty advanced. Really... I mean, the one spear point is the one they've dated to 22,000. It's shaped like a leaf.
Yeah.
It's very advanced.
Yeah. I mean, but this doesn't really surprise us, given that we've recently reviewed other discoveries that suggest that human beings were in North America a long time ago.
Yeah, we've got proven dating of footprints in white sands to 23,000. We've got the controversial Cerruti site, which is as old as 130,000. And then we just talked about a mammoth site nearby here in northern New Mexico. How old was that one? 37,000?
I can't remember. I'm so bad at remembering numbers.
I think it's 37,000 years ago. There were people crushing bones up just about an hour from here.
Yeah.
Pretty fascinating. So let's kick off the show with the first topic, the unexpected spike in global warming. And I'll start sharing. Can you see the ship tracks?
Yeah.
Well, you can see them because this is a picture from several years ago when they existed.
Yeah.
But since 2021, there has been a ban on bunker type fuels, which are extremely dirty diesels, which produce these ship tracks. The ban was due to human health. And what they inadvertently did is potentially some geoengineering.
Yeah, the specific change is a reduction in sulfur dioxide in the fuels. So it's down to like 0.5%.
Yeah, it went from 3.5 to 0.5.
Yeah.
And what's the problem with getting through the article and the paper? Here's the paper, abrupt reduction in shipping emissions as an inadvertent geoengineering termination shock and produces substantial radiative warming. It begins in the abstract talking about man-made CO2 and global warming. And so you really can't dissect what's true and what's false because they begin with the false narrative.
Right. Well, and frankly, the paper really has some issues in the sense that they're solely relying on correlation, right? So they're saying, look, we stopped using we stopped using fuels with as much sulfur in them as they used to have. And that coincided with a warming trend, which is probably debatable. And further, when they went to analyze this, lo and behold, they used a model, right? Like a model that is based on anthropogenic warming theory, and correlated that with satellite observations. So, and then they developed this whole explanation based on that. But the model very well may be incorrect. So what are we talking about here? We're just talking about a bunch of correlations that are just made up.
Yeah, and here's their radiation graph in the paper. You can see this, right?
Yeah.
The dotted line represents when they passed the law that banned the dirty fuels.
Mm-hmm.
And you can see the radiation continues to drop.
Yeah.
Before it rises.
I love it when people use graphs to illustrate their point and it actually does the opposite. It cracks me up. It's like when the Center for, what is it?
Digital hate? Countering digital hate?
Countering digital hate highlighted us and Tony Heller, and they're criticizing what Tony Heller's his claims about, I don't remember, it was the Arctic or the Antarctic sea ice, and then they show a graph from one of his videos that exactly proves what he was saying. It's like, way to edit yourself.
Yeah, again, another drop in radiative forcing here in this graph, another drop here, all after a year after the ban.
Yeah.
So this is really bad data to prove your point, because it doesn't. It shows that there's something else that is causing this variability.
Yeah. Yeah. I mean, and it's very clear too that they jumped all over this because they were like, "Oh, look, there's a warming trend in 2023. Yeah, this must be the reason why." It's like, what? There could be like 1,000 reasons why.
Well, critically thinking, if you eliminate these ship tracks, the sun is going to reach the ocean and it's going to heat the sea surface.
Yeah.
We can all agree on that.
Yeah.
The paper doesn't talk about the sea surface heating. It talks about general radiative heating in the atmosphere.
Yeah. Oh, and just to clarify for our audience, the ship tracks are a brightening of clouds due to sulfur dioxide aerosols.
Yeah, the same thing as a quote unquote chemtrail or contrail, except from a ship.
Right.
So these are ship contrails, which are now, for the most part, eliminated across the oceans. And what you're going to get is hotter sea surface temperatures. So we've seen these global warming maniacs this year publishing this graph all across all social media platforms, showing this rapid spike in March and April in the sea surface temperature.
Wow, what do you know? It's the beginning of spring.
Yeah, the only problem is this has nothing to do with the elimination of ship tracks. It's an aberration just in the last few months. The temperature is dropping back down a little. We were in El Nino, which means extremely high sea surface temperatures. We were in triple dip. That means consecutive year after year of hot sea surface temperatures. So there are many other explanations for why the ocean got hot here. And it's 0.2 degrees C. So 1/5 of a degree C.
Right.
Yeah.
Right. Which in the grand scheme of things, this is a pretty small amount.
So let's talk about this record sea surface warming in April of 2023. Since the beginning of 2023, the mean temperature of the ocean surface has surpassed the previous record of 21 C back in 2016. Do you know what 2016 is? That was another major El Nino, which caused global temperatures to spike. So and then, of course, they're going to blame it on us.
Yeah.
The natural variability gets ignored and we get blamed.
Well, that's what I was just about to say. It's crazy that we are scientifically aware of natural variability, because we are aware of El Nino, La Nina, El Nino, but somehow that's not part of the picture here. And like that has been completely eliminated as a variable. How can you run a model and eliminate that variable when we very well know that's part of the picture? That's crazy.
Right. The longer scale ocean cycles are even have a greater effect on climate, like the AMO and the PDO.
Yeah.
those are like multi-decadal cycles that if you don't add all of these factors into your model, it's garbage in, garbage out.
Exactly.
So, yeah, it's your fault. No,
I have to admit, I didn't even like, I read through like the first like 2 pages of this paper and then I just stopped because I was like, this is garbage right from the beginning.
Right. And they go on to suggest that, oh, now that we've eliminated this sulfur dioxide and we're getting this warming effect, all we have to do is put some stuff into the atmosphere to do some geoengineering to counter it.
I mean, it's like, it's hilarious because supposedly they remove the sulfur dioxide because it's bad for our health and the environment, but oh, we should put it back. And I mean, all of this stuff with like, you know, Bill Gates suggesting that we put like, was it his idea to put salt in the atmosphere or whatever, like ridiculous. I mean, in light of the fact that we're failing to account in the models for natural variability that we're already aware of, that the models are already garbage. So like you said, garbage in, garbage out. We've got garbage models, and then we're going to use those models to throw stuff into the atmosphere to modify the climate. Like we have no idea, maybe I shouldn't say we, but no idea what we're doing.
No
Which
idea.
is in and of itself is scary, you know? I mean, especially given that obviously the global elites know that this is a hoax, and yet they're still going to go ahead with putting new aerosols into the atmosphere because, I don't know, maybe it might reduce the temperature on Earth. It's very strange.
You just got to follow the money. Someone is making money from all this nonsense.
Oh, yeah. Tons of money, obviously. Yeah.
All right, let's move on to the next topic. I don't think we have anything else to talk about there, do you?
No.
All right. May 22nd, 2024, MIT News put out this article. The origin of the sun's magnetic field could lie close to its surface. Sunspots and flares could be a product of a shallow magnetic field, according to surprising new findings that may help scientists predict space weather. That's good news.
Mm-hmm.
And this is also poignant because we are now at solar max. We just came off of the superstorm of May 2024, which was the largest auroral display since the Carrington event.
Yeah, I was thinking about that earlier too, right? Because the Carrington event, you get aurora all the way down into the tropics. I don't think we got quite that far as I'm aware.
There was aurora all the way to the equator.
There was? Okay. I thought maybe the furthest south it was in the northern hemisphere was Mexico, but I guess I'm wrong.
Yeah, it took a few days for those accounts to come in completely, but the same thing happened during the Carrington event, it was continued over 3 days.
Right. So that's the difference here, right? I mean, this wasn't nearly as strong as a Carrington event by any stretch of the imagination, but it is interesting that the aurora did reach as far as it did.
And if we compare it to the Halloween solar storm of 2003, which was actually stronger by a small amount, that storm did not produce auroras that went all the way down to the equator.
Yeah.
So this is telling us that the waning magnetosphere is it's obvious the amount the magnetosphere has waned since 2003 alone.
Yeah.
That's just 2 decades.
Yeah.
So can we imagine what it would be like 2 decades from now?
Right.
That is the question.
Yeah.
So the reason I find this interesting, should we talk about the paper? Where is it?
Sure, if you'd like.
All right, let me open it up. I didn't have it up here. The solar dynamo begins near the surface. The magnetic dynamo cycle of the sun features a distinct pattern, a propagation region of sunspots emerging around 30 degrees latitude, and it vanishes near the equator every 11 years. You double this, and it's a full solar polar reversal, 22-year Hale cycle. Half of it is just half of the reversal, and that is what they're talking about here. So why does that occur? That's due to the magnetic field on the sun. It says that longitudinal flows called called torsional oscillations, closely shadow sunspot migration, undoubtedly sharing a common cause. Contrary to theories suggesting deep origins of these phenomena, helioseismology pinpoints low-latitude torsional oscillations to the outer 5 to 10% of the sun. That means near the near-surface shear layer.
Yeah.
Now, the sun we're looking at, this is interesting. We're looking at the corona, which really isn't the surface.
Mm-hmm.
The surface is beneath that.
Yeah.
A lot of people don't know that.
Yeah.
What's also interesting is that the corona is millions and millions of degrees, and it gets colder as you go towards the surface.
Yeah.
Making it thermodynamically impossible for the sun to be a nuclear reactor, creating the energy in the center and propagating it outwards.
Exactly.
But
Right.
yet, for 100 years, papers have been written about how this impossibility occurs.
Right.
I don't get it. So the heat comes from the center, it goes through the cold surface and then becomes millions of degrees in the atmosphere.
Right. But it's a thermonuclear event going on in the middle somehow.
That's crazy.
It's like, what?
Yeah, it's crazy.
Yeah.
So until we change the paradigm of cosmology, I don't think we're going to get anywhere. And the greatest thing that we know about is the electric universe or plasma universe model of cosmology.
Mm-hmm.
What that model does is, instead of scientists being baffled on every new discovery, it literally explains why
Mm-hmm.
they're baffled.
Mm-hmm. I mean, electric universe theory is very unique in science today, in the sense that it basically approaches like a universal physics, which is something that we've been lacking entirely, right? We have different rules for the quantum level, for the level at which we live, for the macro level. So we have all of these different fields of science to explain various phenomena. Meanwhile, electric universe theory can explain them all. It's entirely scalable.
Plasma is scalable at every level.
Yeah.
So if you're out there, Google plasma scaling.
Yeah.
So that means from the sub-microscopic, the atomic level, all the way up to the universe level.
Yeah. Yeah.
Every level.
And in the same way, like this paper would certainly be a part of that, especially in the sense that what they're sort of talking about is, like, imagine you have kind of a couple of different layers close to in the corona that are, and it's all plasma, and these different plasma layers are interacting with each other electromagnetically, and then that is what's creating the magnetic field of the sun, as well as all of the phenomena that we see, like sunspots and flares and all of that.
Right. So with the advancement of all of our new telescopes in the last 2 decades, we've determined that the universe consists of a filamentary, that is the base design. It's a filamentary design where the entire universe is connected by what appears to be filaments, strings. And these strings, as explained in the plasma cosmology model, are all Birkeland currents, with energy moving throughout the universe, potentially instantaneously or at relativistic speeds. And so it's these Birkeland currents that form stellar Z-pinches, and that would be the illumination of a star within the Birkeland current. So if you get a Z-pinch, you would form a star. Then you could form planets, planetoids, other stars, capture stars, due to the gravitational effects, electromagnetic gravitational effects of the Z-pinch. So I think, and this explains everything, right? The electric model here explains that gravity is a side effect of the electrical phenomenon.
Right. Well, and it also, I think it also helps explain potentially the idea, and people may not agree with me on this, but okay, like this stellar Z-pinch that would form a star, like ultimately at the end of the day, that is also going to cause a condensation of energy that would create matter, right?
Yeah, I mean, it would be the idea that we have discussed that the core of the Earth may be one of these stellar pinches at the center of planets. And there could literally be the transmutation of elements at the center of this plasmoid.
Right. Right. And, you know, we might even see this in a planet like Jupiter, right? Like Jupiter or even Saturn appears to be like a dead star, right? That's like it's like condensing into, it's, you know, gas giant, but condensing into a planet over time.
Yeah. And maybe the core of those gas giants are the rocky planets that we now live on.
Right. Could very well be.
So I like the paper. I don't like the science, but I like the fact that they're now saying that this stellar dynamo has gone from a very deep depth up towards the surface. Within 3,500 kilometers of the surface, I believe. That's the number. Did you find the number?
I don't know. I don't remember.
Let me just scroll down. Okay, I'm not going to find it. Yeah, so they change. So the solar dynamo begins near the surface. They just need to change the cosmology they're using in order to understand why that's happening.
Yeah. It does say that the convection zone would be like the top third of the radius of the sun, and that would extend about 200,000 kilometers below the surface.
I thought that was the old idea.
It appears not here, but now I'm confused.
Well, if you look at the math in the paper, there's good reason to be confused.
Yeah, there's that. Yeah, I will say that this paper is rather over my head, and so it's a little bit hard for me to interpret entirely, but...
Well, the idea that they're now claiming that there is a magnetic field close to the surface is evidence for the electric universe. I wonder, I'd like to see, I'm pretty sure the Thunderbolts project is going to have a video. Someone will do a video on this paper as it relates to EU theory.
Yeah, that would be nice to see.
So if the entire universe is connected through Birkeland currents, each of these Birkeland currents is scalable. So from galaxy to galaxy, there'll be different scale Birkeland currents. And so there's Birkeland currents emanating from the galactic centers out into solar systems to other stars. And then there's Birkeland currents from those stars to other planets at a different scale. And so on and so forth. Humans have magnetic fields, and maybe we have mini Birkeland currents that we're generating from our crown chakra that connect to the poles of our planet.
Right. I mean, that would make perfect sense to me, especially if you can't escape the fact that all life are electrical creatures, right? We are all electrical creatures. When we have flares and geomagnetic storms, we are physically affected by these things. I certainly am. So that's only makes sense, right? Because we're all made of atoms that all have electromagnetism at their core in some way. So
yes, a human is like a mini universe.
Yeah.
If all of the atoms and the orbital shells, billions and trillions of them in each human, is representative of, let's say, galaxies in the universe.
Yeah. Well, and think about the fact too that in reality, even though we're these like supposedly solid human beings, we're actually largely just space, which is a weird thing to think about.
We are
right? But atoms are largely space.
Electrochemical bags of water. We're not even that solid.
Yeah, exactly. Which is fascinating in and of itself.
Yeah, well, birds aren't real.
Birds aren't real?
I just figured I'd throw in a conspiracy theory there.
Okay.
So until we switch cosmologies from the standard model to plasma cosmology or the EU model, we're going nowhere.
Yeah.
So get the memo.
Yeah. Yeah. Cosmology is a mess. It's like it's a comedy of errors, essentially, right? It's errors built on top of errors on top of errors. That's why we end up with theories like, the universe is largely dark matter that we never see and we've never been able to detect anywhere at all at any point. And yet we keep looking for it.
It
It's like,
might
okay,
be.
maybe the equations that suggest that there's all this matter that we can't find, that we've just substituted this dark matter concept for, maybe it isn't really there. Maybe the equations are wrong.
Maybe it's the powers that be are preventing us from changing the paradigm on purpose for a reason. And I
Maybe.
believe this, and the deeper I dive into these rabbit holes, especially listening to what's his name? The guy with the MH370, Ashton Forbes.
Mm-hmm.
He's been diving down the deep hole of wormholes and all this stuff. And all that stuff exists in EU theory and plasma cosmology.
Mm-hmm.
There is no Big Bang. So what that means is that maybe the government has this technology which would reveal the standard model incorrect, and it's top secret and they can't share it.
Right. That could be.
Yeah. Well, we're hacking it, and once AI takes over, AI is going to spill the beans once it finds out.
That's an interesting thought. Yeah, that makes sense.
So it's just a matter of time. The singularity is in like 6 years, but I think that the empire that we live in will end before that.
I think so.
Yeah. All right. This is a really happy show. The next topic is the speed of Earth's rotation. For those that don't know, the speed of Earth's rotation varies. It varies up to 5 milliseconds annually, and it has longer decadal swings.
Mm-hmm.
And so a paper coming out 4 years ago tried to determine if super geomagnetic storms affect the rotation of Earth. And they simply used a correlation causation kind of, that's what they used. They said, we've got this data set, we're going to lay it over the speed of the Earth and see if there's a correlation.
Mm-hmm.
And they found one.
Mm-hmm.
They found the most significant shift in Earth's rotation in the last few decades happened at the same exact time of the 2003 superstorm of October 2003, the Halloween superstorm.
Mm-hmm.
Here you can see the average speed of Earth's rotation since the mid-1800s.
By the way, it's interesting to note that the speed did slow down after the Carrington event as well, based on this graph.
Yeah, so 1859 right here, dramatic increase over a period of the next 2 or 3 years in speed, and then the decrease.
Yeah.
Now, an increase in speed.
Oh, except this is length of day. This is a length of day graph. So the length of day.
Yeah, length of day.
Yeah.
So you gain milliseconds, increase the length of day, or decrease the length of day.
Yes.
Now, when you increase the length of day, that means the Earth slows down.
Mm-hmm.
Everyone get that? So the idea here is that when you have a superstorm, the sun shoots out a pillow of plasma so dense that when it hits the sun, it changes the angular momentum and slows the planet down.
Well, this idea actually makes so much sense at the most basic level, right? You have Lorentz force, right? Which basically tells you that electricity and magnetism does affect physical force and angular momentum, right? So, you know, if you have a wire that's going this way towards you in the screen, the direction of my fingers, that means that you have a magnetic force that's going perpendicular to that this way. And that means that there's also going to be a physical force going this way in the direction of my thumb. Now, that's a much simpler situation than, you know, a rotating Earth. But basically what that's telling you is that it can change the angular momentum of a spinning object.
Yeah, exactly. That was a great physics lesson. I'll read the abstract now so we can all get up to speed on the paper. Mm-hmm. Because you can understand this abstract. It's not too verbose.
Yeah.
A connection between solar activity and the decadal length of day variation is investigated, just like I said. Statistical comparison of length of day with various geomagnetic and solar activity indices was done for the last 140 years. A jump in length of day is found at the moment of geomagnetic storms. The largest one for the last few decades that happened in late October 2003 called the Halloween storm. This change in rotational velocity of the Earth cannot be explained by any known atmospheric or oceanic influences. Moreover, such a jump in the length of day is a unique one for the few recent years. It's worded really bizarre, like it was translated.
It's bad. The whole paper is poorly translated, or the authors just their English was just not very good. So there's a few places in here where it's a little confusing.
Or it's Russia to English.
Yeah.
Either way.
Yeah.
It is supposed that the jump in length of day can be caused by a transfer of angular momentum between solar wind and the solid Earth. That's amazing, because if this is true, and it's obvious, think of it this way. A superstorm is plasma and has density.
Yeah.
So think of it as a giant pillow. If the Earth is spinning and you start to push a pillow on the Earth, it's going to slow it down.
Yeah.
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 What's interesting, if we can find 1859 here,
Yeah.
it's right here on the transition.
Yeah.
It's the pillow effect. It slowed the Earth for 3 years at least.
Yeah.
That's crazy.
Yeah. Also, just for sort of comparison, the Halloween storm, this paper notes, involved 80 CMEs. 80
Yeah.
of them, right? Like the event that we had just had 2 weeks ago was what, like 4 or 5 CMEs?
It was 13 over the whole course of
13.
it.
Okay. Yeah.
Or
So
maybe 12 or 13 over the whole course.
regardless,
But
the
superstorm part was just a few of them.
Yeah.
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 Here we can see that superstorm here. This is the plasma speed in kilometers per second, and it spiked over 1,000.
Mm-hmm.
So definitely probably hit KP9 maximum.
Yeah.
There is no KP10.
Right.
I saw some posts on Twitter, people saying, I think it was KP11.
Well, I mean, it's interesting because I could see a reason to change the KP scale simply because, these kinds of superstorm events we don't see very often. We're not even really all that familiar with like how bad it can get. We only know of 3 superstorm events: the Carrington event, the 1989 event, and the Halloween event. That's all we know, right? Like,
well,
so
in modern times where we had instruments, like, yes.
Right. So, I mean, my point is that we don't have many examples of how severely geez, I can't speak today. I'm a little tired. I apologize. But how severely the magnetofield can be disturbed. So it may be that there's a lot of levels within KP9. Maybe that scale needs to change.
Yeah, it does. Because with the waning magnetosphere, the effects are going to get more and more intense.
Yeah.
So it's not apples to apples.
No.
From 89 till today, the magnetosphere is much weaker.
Yeah.
So if we had an 89 Quebec blackout storm, whatever that type of storm was today, we would have a blackout.
Yeah.
Yeah.
No question.
Okay, so the first graph here is plasma speed. There you can see the spike of the geomagnetic storm. And below, they laid out length of day. You can see a spike here, a very big one, a 1 millisecond spike around the same time. And here they lay over the 2 graphs.
Mm-hmm.
So the red line is geophysical excitation. No, the red line is the solar wind speed. Is that correct? And no, the green line is solar wind and the red line is spin. What I find weird is that the Earth slows down before the plasma speed maxes out.
Yeah, that is interesting.
It could be a fact of the data collection, the way they do it, because we notice plasma fronts as they're approaching Earth on our data sets when the plasma hits the satellite, not when it hits Earth. So it's still far away from Earth when we say it hit on our telemetry.
Yeah.
But it didn't hit yet.
Yeah.
So
it's
maybe
funny.
that has something to do with it.
Maybe.
And again, correlation is not causation, but like they say in the abstract, there is no physical process on Earth that can do this.
Well, and that makes sense, right? Like what I mean, the what we're saying essentially is it's coming outside of Earth, not from Earth itself. And for the spin of an object, that makes a lot of sense. And I'm not saying that you can't change the spin of an object internally, but well, it also illustrates the not the I don't mean gravity in the sense of actual gravity, but the sheer magnitude of the sun in and of itself, right? Like that one of these superstorms can impact Earth this much. It illustrates something about the power of the sun. And frankly, these events, these superstorm events, are probably not, they're probably relatively small in terms of what the sun can actually produce.
Exactly. So now that we've got the concept, and we do have evidence of 2003, 89, right, in Carrington, the paper is showing that the plasma is potentially slowing the Earth for years on these big events. We can do a science experiment live on radio with everyone. If this is true, and I can find the data set of how fast the Earth has been spinning day after day, and it has slowed down considerably in the last week or so, we will have more evidence to prove that this is what's like actually happening because we just had a superstorm.
Yeah. Although I think you could argue that the superstorm we had didn't nearly approach the magnitude that did any of the previous three that we were talking about.
It was exactly the same size and scale as 2003. It was only off by 2%. Weaker.
Really? Even though there were 80 CMEs for the 2003 event?
Yeah, because there is a measurement of the power. And you can look at the graph and see that it was about 98% equivalent. And the plasma speed approached 1,000 and everything was pretty much the same.
Right. Especially with the plasma speed. I definitely noticed that too.
Yeah,
the other
so
thing
it should slow the Earth. And
yeah,
what you can come and see, this is the length of day on Earth. I'm going to back it all the way up to 1990. You can see back in the 90s here, the Earth was 0.184 milliseconds. That's added to 20, that's added onto the day. So that means the Earth was very slow back in the 90s. And watch what happens. It's speeding up. And then all the way in the 2000s, it's shorter than a 24-hour day. We're spinning really fast. And look at what just happened in 2024. It reversed.
Nice.
And it is slowed down considerably by 0.6 milliseconds today.
Yeah.
And we were just at negative last year on average. So the superstorm just slowed us down a whole bunch.
I mean, the other thing that's sort of interesting to think about with this is that it kind of illustrates this idea that time is relative, right? Like, we always like laugh about when you get older, time seems to go faster or whatever. Obviously, it goes faster or slower, right? The length of the day is actually changing.
Right. Well, look at this. The fastest day we've seen in decades was March 11th of this year.
Yeah.
Or it was the slowest day, plus 1.28.
Yeah. Yeah.
That's kind of interesting because we've been negative every year for all the way back to 2020. That means Earth has been spinning very fast. And all of a sudden this year it's slowed down, which goes against the trend for the entire time.
Yeah, right. So I mean, obviously it begs for a cause, and a superstorm would seem to be it.
There's very little change from the 2000. Here, let's look at this. So
I gotta pull this up a little bit. I can't see it very well.
2003. There's really limited effect from 2003 on the length of day here. It slows down. It slows down quite considerably. Yeah, for 15 years, it gets slower and slower. I don't know if that's a direct effect from the superstorm.
Well, if you go back to that first graph you were showing before, figure 1, that like shows, a much, here in about 1860 or shortly thereafter, we get this major slowdown, and then it happens again after 2003. But
No, this is a speed up. Dropping down is getting faster.
I'm talking about after 1860, when the length of day increases, that peak.
Oh, right
its
here?
length of day increases. So the spin of the Earth is slowing down.
Yes.
Right after, and then around, like, I mean, I wish this graph extended out a little bit further, but after 2000, it does slow down, but not at such a strong peak. So maybe there's a much more gradual slowdown after the 2003 event instead of a kind of a spiked slowdown.
Ah, that might be it. And what is causing the rest of the variability?
Well, I'm wondering about that. What is causing this the speeding up, that happens, let's say, after 1890?
There's two ideas on what is controlling the rotation, and one of them has to do with you accepting the fact that there's a liquid outer core and a solid inner core of iron.
Mm-hmm.
And we talked about this on a show. The core of the Earth spins at a different speed than the surface of the Earth.
Right.
It's either slightly faster or slightly slower, and it may be whatever is powering the speed of the core that affects the surface of the Earth.
Mm-hmm.
And there's a lag time. The core slows down, and a few decades later, the Earth slows down, or something like that.
Yeah.
But well, I don't believe any of that. So.
Right. Well, and then also this graph also leads me to question, okay, what happened at about 1900? Like maybe there was a solar event that we missed.
Yeah, it's the centennial minimum right here. So
yeah,
from 1900 to 1915 was a very cold time on Earth. Solar minimum, the centennial minimum. And so solar activity might be controlling this as well. If the sun is responsible for slowing the Earth when it has a superstorm, maybe the sun is responsible for accelerating the spin as well.
Well, and during a solar minimum, the magnetosphere tends to be weak, right? So
yep.
So maybe that, and that brings in more cosmic rays and more energy and matter from the sun in and of itself.
Well, maybe a strong magnetosphere slows the Earth's spin as well. And when it gets weak, it speeds up. There's less friction from the currents.
Wow. So it'd be really interesting to overlay the length of day graph with a solar min and maximum graph. That would be pretty interesting.
Definitely. That's for another show.
Yeah.
So it's interesting. And I think I don't remember where I read that. I wish I could read it. Let's see. Okay. Currently, the first group of hypotheses is preferred. Currently, there are two sets of hypotheses that attempt to explain the cause of the oscillations of Earth's rotation. The first group suggests that the source of energy exciting these variations is the liquid core of Earth. That's the one I just said. Mm-hmm. The second group of hypotheses suggests that the excitation source is of solar origin. So there we go. It's one or the other.
Well, and you can probably argue that the excitation source being of solar origin would affect the liquid core, right? The same way that, say, the muons can affect the volcanic activity.
Yeah. And this also has to do with electricity. So if you dive deeper in the paper, what they're saying is, in one case, you were talking about the physics of it, the Lorentz force.
Yeah.
What they're saying is that these superstorms dump energy into the poles through a Birkeland current. They don't say it, but that's how it happens. And then that energy rushes through, guess this, the surface of the Earth. The magnetism is on the surface, which is coming externally, which we just talked about is happening at the sun, and they're not putting these pieces together.
Right.
But it's the electricity that runs through the surface, the telluric currents, that acts against the plasma energy. So it's an electrostatic force as well that slows the Earth. That's one of the ways they describe it here.
Yeah.
But the same thing that we talked about on the sun is also happening here on the Earth, just in a different way.
Right.
Interesting.
Again, scalable, right? Like, this is actually really important.
So we are getting closer to the truth. We just need to keep looking.
Yeah.
All right,
Cool paper.
let's finish up the show with this awesome discovery, and we're going to dedicate it to Dennis Stanford, who has known that people in the Americas have been here long before Clovis first. He was head of the Smithsonian for years, and he just kept quiet. These scientists just keep quiet so they can keep their job.
I know. It's so frustrating. It's really, really frustrating.
They even allude to it in this paper here. They talk about how nasty these people can be.
Mhm.
I mean, all the Clovis first people, it's like 90% of the field, right? And you come out with a paper that says people were here you have dates to 25,000 in some of these stratigraphic layers. And they just disregard it because they say, well, that's impossible because humans just got here 14,000 years ago.
Well, I really like. Okay, so this article centers around a researcher named Darren Lowry, right?
Yep.
And I like how he sort of responds to potentially to the controversy. He says, following a non-peer-reviewed publication of his findings, Lowry told the Washington Post that, quote, life's too short to debate with other experts over the peer review process. He's like, I don't like, okay, we can do a peer review and you can peer review my article, but the reality is I found these artifacts. I found them and was able to date them to 22,000 years ago, right? Because like one of these pieces was in a piece of charcoal that was 22,000 years old. That's relatively easy to date. You know, other pieces he found in certain sedimentary layers that are easy to date. And it's like, if you want to try to pick him apart on dating, you can try, but it's kind of silly.
Yeah. Geologist
You know?
Darren Lowry made 93 trips to Parsons Island with his team. And they found 286 artifacts in the Chesapeake Bay. The majority of them, the ones that were above, listen to this, that were several feet above the old ones, were Clovis.
Yeah.
They dated to 14,000 years ago, and
Yeah.
they were above this point.
Yes.
This leaf point was literally sticking out of the cliff in situ. In situ means it's exactly where it was left at the time it was deposited.
Mm-hmm.
And they happened to find a piece of charcoal right here, and it dated this in situ point, remember, below the Clovis to 22,000 years ago.
Right.
So that's the simple science. There is no controversy. It is what it is.
Yeah, and it's also about the same time frame as the White Sands footprints, you know? So it's like that alone, now we're talking about disparate parts of North America. So that alone clearly indicates that not only were humans here at 22,000 years ago, but they had been here for quite some time.
And
otherwise, if they weren't, they would likely be, you know, sort of relegated to one particular place. Yeah, and they're like, well, how did they get to Maryland? It's like, what? Like, why? I really have a problem with the assumption that there was some long period of time where there were no humans in North America. I just think that that's completely faulty. But it's obviously a function of the out of Africa hypothesis.
Exactly. And so at this time period, 22,000 years ago, we are at glacial maximum. It is the lowest sea level period ever on Earth.
Which is going to make travel easier in and of itself.
Yeah, you can walk everywhere on the shoreline, everywhere. And so this is not going to be an island. This is not going to be in Chesapeake Bay. This is going to be high and dry, which is the stratigraphy they found. They found that this was near a pond or a lake on the shore, and that there were drainages. So at this time, the Chesapeake Bay was a creek.
Yeah.
Because sea level was 330 feet or more lower.
Yeah.
It was simply a creek going out to wherever the bay was at that time.
Yeah.
And so this wasn't an island. It's interesting. And the island is rapidly going away. So I found the paper. I found all of the artifacts. This paper is amazing. It is, I think, 100 pages long. It's so long. I kept scrolling and scrolling because remember, there's Dennis Stanford. This guy has known that there were there was people that were 16, 17,000 years ago here in America in 1980, he told me.
Yeah.
In the 80s, he knew it. But no one, if you mentioned it, you got attacked. So you didn't say anything.
Yeah. Because you found a Clovis Point or a part of a Clovis Point yourself. Where was that again?
Norristown.
In Pennsylvania. In a cave, right? Which is what led you to Dennis Stanford.
Yeah,
I mean,
it
he's
took
known
him
this
over a year to respond to me, but he did.
Yeah. Yeah.
And he told me that he's like, yeah, we've got tons of these and older. So once you start looking under Clovis and you find other stuff, they were just grouping it in with the Clovis because they didn't want to admit that there's a different culture beneath them. There can't be. There's no way for them to have gotten here. That's what they said. Meanwhile, Thor Heyerdahl in the 70s tied some reeds together and went from Easter Island to South America.
Right.
But there's no way the ancients could have gotten here.
It's such a stupid assumption. It's like, obviously, if you're finding something under the Clovis layer, like, you can't continue to deny that there were people here. It's so ridiculous. Like, maybe you need to throw the hypothesis that, human beings weren't here away. Like, just throw it away. It's clearly incorrect. It's so frustrating.
Here they have all the dating calibrated that they've done, laid out in the paper, because remember, they went here, I forget, what did I say, 96 times?
No, I think it was like 93 times, yeah.
Almost 300 artifacts. And they're not just chumpy artifacts. If I can scroll through the first 174 pages here, we'll get to some. There's the location right there in the Chesapeake Bay. That's the Delmarva Peninsula, they call that, don't they?
Yeah. Yeah.
This place is amazing to do geology. You can find all kind of ice age mammal bones, mammoth teeth, literally weathering out of the shoreline cliffs. One of the most famous sites is the Calvert Cliffs. I think it might be blocked off to the public now because it got a little out of hand. You could find giant megalodon teeth. Those are the big black great white shark's teeth that are like 6 inches, just lying on the beach. So after a storm, you get there early in the morning at low tide and find whale bones. It's an amazing place to go.
Yeah. Well, and the other thing that's just really fortunate too is that this is private land, Parsons Island. So he obviously has a relationship with the people who own it that are like, yeah, please come dig. So that's just really fortunate.
It's rapidly going away. It soon won't exist. Look at the peninsula here in 92, gone.
Wow.
And they found pictures of the island as far back as the early 1800s. I'll go through that. It was once part of a peninsula and not even an island.
Yeah.
In recent times, back here on this map, it was part of the peninsula. In 1673, it wasn't an island.
I mean,
Go ahead.
This is a pretty, as far as I understand it, this is a pretty normal phenomena, especially for like peninsulas. Like inside Lake Erie, there's Presqua Isle, which is a peninsula, but like the boundaries of the peninsula have changed dramatically over the years, and it just has to do with water currents and flow.
Well, and storms. If
If you're
in the tidal zone, there's going to be destruction, and then there's going to be creation.
Yeah.
And it's because of longshore current. As the stuff gets eroded, it moves south down the coast and gets deposited somewhere else.
Well, and then one of the
go ahead.
I was just going to say, I don't know if it's a benefit per se, but one of the things that comes out of that is ecological diversity, because you have a environment that's constantly changing.
Yeah, and renewing itself.
Yeah.
What I find fascinating is there are still cypress trees here.
Wow.
These cypress root balls date back to the last magnetic reversal or excursion that created a mass extinction. These date back to 47,000 years old, and they're still there. That is
crazy.
A 40,000-year-old stump. They dated them.
Yeah.
That's insane.
Huh.
There's another one.
You're making me wonder now. I think there's
43,500 plus or minus.
That's amazing. You're making me wonder now. I was just recalling there's some cypress stumps in the Schuylkill down at Bartram's Garden in Philadelphia.
Probably the same date, because they don't live here anymore.
Yeah.
They went extinct at glacial max. And so here's that level, that horizon down here where the bald cypress would be in the stratigraphy, 43,500. Here is the younger Dryas layer, 12,008. So they're finding the Clovis down in here, and then the older stuff down in here.
Wow.
And then the oldest stuff, the Cypress, 43,500.
Wow.
Taxodium distichum, the bald cypress.
Amazing.
Yeah, because to find a bald cypress, I think you got to go south, maybe 400 more miles, South Carolina.
I don't know where they start. I mean, I know they're certainly in Louisiana.
Yeah, well, all over the Gulf Coast.
Yeah.
But it was a much different time.
Yeah.
Tropical.
Yes.
Here. And oh, that's the show? Oh, we just got into it.
Tropical then, but here we are, worried about global warming.
Yeah. And there's a mammoth tooth. Make sure to watch the show tonight, 8 p.m. Magnetic Reversal News on YouTube.
See you there.
Darn it.
Listening to Revolution Radio at freedomslips.com. And we'll be right back after this message.